All right, here we go. B here says find the minimum distance d and the point xy that associated with the minimum distance. So building on what we have back here, where we said distance was a function of y, and we had it equal to the square root of 10y squared plus 30y plus 25. As soon as you see that word minimum jump in, that should trigger a few things for you. And so if we're trying to make this the distance as small as possible, that means we're going to try to find the minimum of this radical. And notice what's inside the radical. It's 10y squared plus 30y plus 25. That's a quadratic. So how do we find the minimum in a quadratic? Well, if it's is it opening upward? Yeah, it's opening upward. It's got a positive a value here. And so it's going to be opening upwards. We need to find where our vertex is at. So to do that, let's kind of approach it as though it was 10x squared plus 30x plus 25, and we're used to seeing parabolas in that form. We're looking for just the minimum again, though. So our vertex is at negative b over 2a, and our negative b is, so negative 30 over 2 times a, and that's 2 times 10, and that all reduces down to negative 3 halves. That's going to be our y value. We've solved for y now. To find the minimum, we need to plug that value back in, and we can get down to our smallest quadratic here. So that's going to be our y value in the point, that's negative 3 halves. And to find out actually what the smallest distance is in terms of y, we're going to plug that back in. So we have, let's see, is there room over here? No. So we'll do it over here. We've got 10 times negative 3 halves squared plus 30 times negative 3 halves plus 25. That's going to be equal to the minimum distance. So minimum distance is equal to negative 3 squared, or 3 halves squared is going to be positive 9/4. And then over here, 30 divided by 2, that's 15. 15 times negative 3 is minus 45. And plus 25. Over here, let's see, 9/4, that's 2.25. Is that right? Let's see, 4 goes into 9 twice, and then a remainder of 1/4. Multiply that by 10, and we get 22 point, well, I guess we'll write that as a new line. Minus 45 plus 25. That is 22.5 minus 45 plus 25. And when we add that all up, our minimum distance is, what is that? The square root. So these are all under the square root. But I'm going to not write those all in there. So we end up with the square root of, this simplifies down to positive 2.5. So that's going to be our minimum distance. And that number, the square root of 2.5, is right around 1.6. I think it's 1.58 something. So there we go. That's our minimum distance. Now, and remember, we found the y value already. We found what the minimum distance would be if, depending on what y was, and we found that that minimum distance happened at negative 3 halves. Okay. Now, what's our x value going to be then? Well, we got to go back to the equation of the line that we know. We knew that x, what was it? X minus 3y equals 5, and we had added 3y to each side. So now we have x equals 3y plus 5. And all we're going to do is plug in our y value. So we have x is equal to 3 times negative 3 halves plus 5. That is x equals negative 9 halves plus 5, which is 10 halves. And we get x equals positive 1/2. So there's our x value, 1/2. So here's our minimum distance was the square root of 2.5 or 2.5, and that the point associated with that distance is 1/2, comma negative 3 halves. So Here's our rough graph, just kind of showing what's going on again. And there's the origin. And then let's see, at half and negative 3/2, so 1.5, right there is our minimum distance. And that's showing the distance there. Now the line itself of x equals 3y plus 5. Let's see, that's going to be, what was it as a, let's put it in slope-intercept form real quick. So it was x equals, or x minus 3y equals 5. We would subtract x and have negative 3y equals negative x plus 5. So y would be equal to 1/3 x plus, minus 5/3. And so it would be coming along here, negative 5/3. That's right. That was 1.5. So there's 2, and it's right around here. And there's the line. And now we found our minimum distance. So that would be a right angle, minimum distance from the origin to our line. All right, I hope that helped.